In this video, I'm going to go over how to determine the chemical formula for a compound that contains a multivalent metal. So, in order to determine the chemical formula for a compound with a multivalent metal in it, we have to consider the Roman numeral in between the first and last name of the compound, or we have to, if given the classical name, we have to determine the charge based on the classical name. Okay, so let's look at some examples. So the first example we have here is we have cuprous oxide. Okay, and that's the classical name. So there are two forms of copper, as we saw in the previous video. There's copper 1 and copper 2. So cuprous is copper 1 and cupric would be copper 2. So from this name we can tell that the copper will have a charge of +1. Okay, so here I can write copper 1 oxide, and so since the copper has a charge of 1 and an oxygen always has a charge of -2, there would be two coppers, so Cu2, so subscript 2 O. Okay, now going on to the next one, we have iron 3 fluoride. So iron has a charge of +3 since the Roman numeral is 3. And so the classical name for this would be ferric. Okay, so ferric oxide. The other form of iron is ferrous. So ferrous is if iron has a charge of +2. And so in this case we know that fluorine always has a charge of -1. So in this case what we would have is we would have Fe F3. Okay, so 1 iron and 3 fluorines. So +3 charge, and each fluorine has a -1 charge. So that's a neutral charge, so it's balanced. Going on to the third one, stannic sulfide. So stannic is tin. There are two forms of tin. There's stannous and stannic. So stannous has a +2 charge, and stannic will have a +4 charge. Okay, so then this would be tin 4. Okay, so tin 4 sulfide. And so sulfur, just like oxygen, has a charge of -2. Okay, so what we would have here is, so since tin has a charge of +4, we would have two sulfurs. Okay, so two sulfurs, each sulfur has a charge of -2, and the tin has a charge of +4. Okay, next one, plumbous bromide. So plumbous is lead. Okay, so there's two forms of lead. There's plumbous, so plumbous has a charge of +2, and there's plumbic, which has a charge of +4. Okay, so this would be lead 2 bromide, and so bromide being a halogen has a -1 charge, so we have Pb and we would have Br2. Okay, next one, lead 4 chloride. So this would be plumbic lead. So plumbic chloride. And so we would write PbCl4. Okay, next one we have chromous nitride. So there are two forms of chromium. So there's chromous and there's chromic. So chromous is +2, chromous is +2 and chromic is +3. Okay, so this is chromium 2 nitride. Okay, so nitrogen, if it's bonding to a metal, will have a charge of -3. Okay, so based on, if we look at the periodic table, we have nitrogen here, and so nitrogen can have a charge of +5 or -3, and so in this case, if it's bonding with a metal, with chromium, it needs to have a charge of -3. So in this case, we would have Cr. So since this is, so crossing over the charges, we would have a 3 here. And for nitrogen, we have a 2. Okay, so 3 and a 2. Okay. Now going on to the last one, we have Baltic Phosphide. So this is cobalt. So there's cobaltous and there's cobaltic. So let's check what the charge would be. So for cobalt 2 ion is cobaltous and cobalt 3 ion is cobaltic. Okay, so this would have a +3 charge. So CO, or actually, cobalt 3 phosphide, and the 3 went away here. Okay, so yeah, so cobalt 3 phosphide, so that would be, so let's check the charge on phosphorus. So phosphorus can have so a +3, +5, or -3, so just like nitrogen. So it's going to have a -3 charge when it's bonding with a metal. So let's write that. So what we would have is, so P. Now since cobalt has a +3 charge and phosphorus is going to have a -3 charge, so what we're going to have is we're just going to have COP. Okay, so the cobalt has a +3 charge and phosphorus has a -3 charge. Okay, so thank you for watching. If you found this video helpful, please give it a like. And check out my next video where I'll go over naming molecular compounds.